So at the end, let's make some concluding remarks about what we have for this formulation, for this lecture. So we do have half of our lectures talking about some basic ideas or examples, and the remaining part talking about linearization. So maybe at this moment you want to ask, what's the point of making so much efforts to do linearization? Why not just stay with a nonlinear program? So the thing is the following. Roughly speaking, when we want to solve a mathematical program, solving a linear program can be considered as the easiest. And then solving a linear integer program, well, that's not so easy, but there are some systematic way for us to do that. However, solving a nonlinear program can be hard, while solving nonlinear integer programs can be very hard. So what does that mean? Even though in this particular course we focus on modeling and applications, but still, when we are trying to apply our models, apply those models that we formulate, if we don't know how to solve that problem, then that model becomes useless in some sense. So in this course, we also mentioned about, for example, how to use Excel solvers or some other tools to solve a mathematical program. If you are able to formulate a program, but you don't know how to solve it, then that's going to make the effort totally wasted. So while some people formulate mathematical programs, they should also at least estimate or understand the difficulty of solving that programs. Otherwise, the applicability would be decreased. So even though in this course we don't talk about how to solve programs, that's about algorithms, that's in later courses. But in general, whenever we are facing an optimization problem, we should try our best to formulate a program that can be easily solved. So if you don't have time to look at later lectures, at least you should be convinced that linear programs are easier than nonlinear programs. Okay? So try your best to do linearization, because that's going to help your models to become more solvable. Being able to estimate the solvability would be very important if you try to become a practitioner about OR in practice. Okay? And if you have some time to go to our second course, which talks about algorithms, then you will see more about why a linear program is easier to be solved, why a integer program is not so easy, why a nonlinear program can be very hard. If you have time, that would be good. If you don't, at least please try to memorize this. Linearization is going to be important if you really want to apply these modeling techniques in practice. So that's the end for today's lecture. Thank you.